Okay, so 7.5 day 2, we are going to expand into, not looking so much at square rooting, but cube roots and rational exponents and how we solve those equations. But first, let's do a little bit of a review from the previous video. So pause here and solve for the following. Okay, so for number 1, I'm going to zoom up real close to that. So I'd start by squaring both sides, right? It's going to undo that square root, and so I get x plus 5 is equal to x. Well, notice what happens when I have to get my variables to one side. My x cancels, and then I'm left with 5 is equal to 0. So hopefully you remember what that means. That means that there's actually no solution here. Tricky first problem. Let's look at number 2. So I would start again by squaring both sides. And so I'm left with x is equal to 2x. And then here I would subtract x to both sides. And I'm left with 0 is equal to 2x. Or I actually like to flip that around. I would write it as 2x is equal to 0 because I like my variables on the left. And I divide by 2 and x is equal to 0. So that is a solution. And oftentimes I get students that'll say no solution. But x can be 0. In number 3, I would start by subtracting 6 to both sides. So I get the square root of 5x is equal to -1. And then I'm going to, in a different color, I'm going to show that I would square both sides. So that cancels, and I'm left with 5x is equal to, and hopefully you remember that I'm actually squaring a -1, not a 1. And so I get +1 out of that. And I would divide both sides by 5, and I get x is equal to 1/5, or maybe you said 0.2. Okay, so let's tackle some new radical equations, not expressions, but equations today. So in this example, we have a cube root. And just like if I had a square root, I am going to undo that by raising both sides to the power of 3. And that simply cancels, and I'm left with x is equal to 27. Okay, so whatever this number is here, that is the power that you're going to raise on both sides. So looking at the next example, I see I'm cube rooting. So again, I'm going to raise both sides to the power of 3. So that this cancels, this gets raised to the power of 3, and I'm left with 2x plus 7 is equal to 27. And make sure that you aren't going too fast and saying that 3 cubed is 9. It's 3 times 3 times 3. So then I'd subtract 7, and I get 2x is equal to 20. Finally, divide by 2, and x is 10. Okay, the next one, I kind of like to consider it a coefficient in front of that radical. So before I can cube both sides, I'm actually going to divide both sides by 2. And so I get cube root of x minus 3 is equal to 2. And then I will cube both sides, and I get x minus 3 is equal to 8. Finally, add 3 to both sides, and x is equal to 11. Okay, in the next example, so here my index is 4. So that means I'm going to raise both sides to the power of 4. And then that cancels. I'm left with 3x plus 3 is equal to 2x minus 7. And so I'll start by getting my variables to one side then, and I get x plus 3 is equal to -7. Finally, subtracting 3 to both sides to get x is equal to -10. All right, so then the last example here, I have a rational exponent. So we kind of have to remember how to write that. Before I actually even bother with that exponent though, I want to get rid of the coefficient. And so I'm going to start by dividing both sides by 7. And so I get x to the power of 3/5 is equal to 8. And then if you remember from the first part of this unit, I can rewrite this as the cube root, my index is 5, okay? And then x to the power of 3. And then that is equal to 8. So since my index is 5, I would start first by taking the power of 5 to both sides. So I get x to the power of 3 is equal to, one second, let's see, 32,768. Then I'm going to cube root both sides. If you don't know how to do that in your calculator, you are going to hit the math button, and then you're going to kind of like arrow down to option 4, which is the cube root button, and then we can go ahead and cube root that number, and we get that x is equal to 32. So let's talk about solving radical equations when it comes to an application problem. So it says in a hurricane, the mean sustained wind velocity, which is just v, okay, is given by the following equation where P is the air pressure, so P, air pressure, in millibars at the center of a hurricane. Estimate the air pressure. So we don't know the air pressure, so we don't know P, but we do know that the wind velocity is 54.5. So that's what's going in right here. So 54.5 is equal to 6.3 times the square root of 1,013 minus P. So the first thing I want to do is I want to isolate basically that square root. And so I'm going to divide both sides by 6.3. So 54.5 divided by 6.3 gives me, let's see, I'm going to round to the nearest, let's do the nearest tenth. So I get 8.7 is equal to the square root of 1,013 minus P. And then I'll square both sides. So now that I've rounded it, 8.7 squared is 75.69 is equal to 1,013 minus P. I'll subtract 1,013 to both sides, and you will get a negative number, but that's okay. You'll see that it'll actually end up flipping. So 1,013, and I get negative 937.31 is equal to negative P. So basically, I'm going to just take the opposite of that, and so P, or my air pressure, is equal to 937.31, and then that's millibars. So for this last problem, why don't you pause the video and try it on your own. Okay, so I would start first by subtracting 1, and I would be left with, we're taking the fourth root of 3x plus 7 is equal to 2. Then I'm going to take the power of 4 to both sides, and I get 3x plus 7 is equal to 16. I will then subtract 7 to both sides, giving me 3x is equal to 9. Divide both sides by 3, and x is 3. So in summary, now that we've done the 2 videos on 7.5, how do we solve? So how to solve radical equations. There's really just 2 steps. Step 1. The most important is just to isolate the radical expression. That has the variable, right? And then step 2 is to raise both sides of the equation to the index of the radical. Okay, by that time, the radical symbol should be gone, and then it's a matter of isolating or solving for the variable.